Hello, good morning.
Good morning, ma'am.
Good morning.
Good morning, ma'am. How are you, ma'am?
I'm fine, thank you. How are you?
I'm good.
Okay, so hello, Zarif.
Hello, ma'am.
What was your problem last time?
मैम अबाउट द मूडल
Yeah.
इशू मैम वो पता नहीं जो है ना साइट कनेक्ट नहीं हो रही थी
No.
लेकिन फिर मैंने जो है ना अबाउट द मिसिंग होमवर्क
हाँ,
मैम माय मदर वाज वेल आई टोल्ड यू
नहीं.
तो मैं ट्रैक
It was not a problem with the site. It was a problem on your side, है ना? So please ensure
यस मैम
आप लोग please follow all the activities since we are using Moodle so much and they're all taking place online. You have to ensure that you have internet. Okay, so Wi-Fi, if you have Wi-Fi at home, you should also have an option for data in case the Wi-Fi becomes weak or so, then you should have the choice to switch to data. Also there were
यस मैम आई स्विच टू डाटा तो फिर चल गया
yes,
था फिर हो गया
yes.
था ठीक
And please plan well in advance because you keep your devices charged again with the UPS backup also. You cannot, these cannot be reasons for any kind of concession or leniency. You have to follow the deadlines. Okay, so this time I opened it, but this is the last time. Okay.
ओके
It's
मैम
your responsibility. You know this. This is not the first time you're doing online work. It was already known from the beginning of this semester. You've also done this in the previous semester. So you should have your, it's not just for you. I'm talking to the whole class. Okay. So you should have your internet. Ensure, I am also right now, I'm working on data because my Wi-Fi just went out. So you have to have both options, and again charging is of course your responsibility, right? And along with charging, you should also know you should have some kind of backup. So you cannot say that my device was not charged or my internet was down, because internet is always like this, so you have to have two options, maybe Wi-Fi plus data. You have to know in your home or wherever you are where you get the best signals and where you can sit down and do this. Okay, is that clear?
यस
So
मैम
please, in the next activity that we will be doing, as I discussed in the last class as well, I can also share this with you. Yeah. Wait. Yeah, you see, I did share this with you last time. This quiz will be opened for only the class time. Okay. Is that clear? So wake up early, have your breakfast, prepare yourself, your devices, everything, and be ready at least 1 hour before the quiz starts so that you don't panic at that time. Is that clear? Because I know it's very natural to panic if you start connecting your devices at the last moment. Okay, so in this case the time you will be given will be restricted and you have to complete your work in that time. Again, this will be on Moodle, and you know the syllabus, we have already discussed this several times. The topics are 6, 7, 8, but again when we match these topics with the chapters, these are the same chapters that were given to you for your homework assessment. And also these are the chapters that we already covered before the holidays and we are now revising these chapters. So we've done this over and over, so please prepare yourself properly. Okay, is that clear? Right, so now I can start with the revision that we are doing. Okay, so you can see the book, right? You can also see that we did some revision last time as well, and we continue with that. So we are talking about the topics and the chapters included in the syllabus for the upcoming quiz. And in this case, you can see that we are talking about angular motion, right? That's one of the main topics, and these topics are overlapping in these chapters. So for example, chapter number 11 is using most of the formulas that we studied in the previous chapters. So for example, we talk about angular momentum in a later chapter, but then angular momentum is based on quantities related to angular motion that we studied in another chapter. So these are all related to each other. So you know what theta is. Theta is angular displacement. You know the units of theta are radians, right? Okay. So since this is a revision, we will just go do an overview of these. We talked about omega last time. Omega is angular velocity. Angular velocity which is similar to linear velocity, which is v. And then we talked about the formulas. We also talked about the fact that these are vector quantities and hence they will have a direction, and the way to determine the direction is known as the right hand rule. And this table is very useful for this purpose. In this table, you can see the equations of motion. Again, the equations of motion were studied in the beginning of this course. Those were the equations of motion for linear motion. So these were based on the variables for linear motion, which are velocity v, displacement x, and acceleration a. The same formulas can be written for angular motion or circular motion or rotational motion. The only difference now is that instead of v, we use the corresponding term or symbol for angular motion, which is omega. Similarly, for acceleration a in linear motion, we have the acceleration alpha in angular motion. And for the displacement x in linear motion, we have the displacement theta in angular motion. So these are the same equations. Again, like, yes, it's not something completely strange. It's similar to what has been done before. Okay, so these are the different equations for these. We are talking about centripetal, for example, the direction of acceleration. And in the case of acceleration in a circular path, we have two components. We have the radial component and we have the tangential component. I also told you what this means. And for the tangential component, the relationship between the two linear and angular components are a is equal to alpha r, and you have a small subscript t which is standing for tangential. If you look at the radial component is along the radius, so this is similar to the centripetal acceleration. So this is given by v squared over r, which can be changed to omega squared over r. Then kinetic energy, we've been doing this from the beginning of the course. Again, the only difference in this case is kinetic energy in the simple mechanics is half mv squared, as we know, right? It depends on the mass and the velocity. So in this case, in circular motion, instead of mass, we talk about the moment of inertia, capital I. Again, you know that the formulas for the moment of inertia of different shaped bodies is different, and these are given in the table that you know in this chapter that we've talked about several times. So instead of m, you will be using capital I, and instead of v, you will be using omega. So this is the equivalent formula for kinetic energy in circular motion. Again, this is the table that I just talked about, and from which you can see the formulas for different shapes, the hoop and the cylinder, and you know, again, you can see different kinds of sphere, for example. So you can see which formula is relevant, and then you can use it for solving any kind of problem that you have. Torque, we talked about torque last time as well. Torque is again an important quantity, and we know that the formula of torque depends upon the moment arm, which is r, the perpendicular distance of application from the application of force, and this is a cross product. Torque is equal to r cross f, so it is a vector quantity. And if it is a vector quantity and this is a cross product, you can write it as rf sine of the angle between those. So you can take a perpendicular, and whenever you have a sine, it means it's a perpendicular component. So we are familiar with this. So torque plays the same role in angular motion that normal force plays in the case of linear motion. So again, we know that there's a relationship between work and kinetic energy. This is known as the work kinetic energy theorem that we've been studying previously as well. We studied this theorem in chapter number 7, for example, and now this theorem can also be written in the same way for circular motion, right? And again, this table is again very useful. It gives you the correspondence between different quantities that we have just discussed. What were those quantities in linear motion, and how you can write them in angular motion. Okay, so so we have covered these terms, these concepts, and these formulas. And now I'm going to apply these to solve some problems. Okay. Oh no. Wait. Let's go to page 322. So now this is, I was reviewing chapter number 10. Now I'm on chapter number 11. Chapter number 11 is about, again, angular motion. And in this case, we are talking about the kinetic energy, just as we discussed, the acceleration, the angular momentum, right? And I also gave you some material related to angular momentum to help you understand this. And then the Newton's second law, again, Newton's second law, the simple version we studied in the beginning of the course, which is F is equal to ma. In this case, because we're talking about angular motion and angular quantities, so this is in terms of the torque and the angular momentum. Again, small l is the angular momentum of one particle. Capital L is the sum of the angular momentum of all the particles. And also we have the concept of center of mass, which we studied in one of the last chapters. And again, if a body is considered to be a system of particles, then the center of mass will be a point in that body, even like the human body or any other body, where that mass is acting, and that will be called the center of mass. So related to this, we can look at a problem. Okay, let's look at this one. We've done this one, right? The cockroach on a disk. Let's look at 11.7. In this case, you have a boy sitting on a stool. The stool can also rotate, and the boy is holding a wheel, right? A bicycle wheel, a circular wheel, and the wheel is rotating in the counterclockwise direction, as you can see in this figure. The boy is stationary in figure A. He is not moving, but he's holding a bicycle wheel, and which is rotating in the counterclockwise direction. As you will remember that when we have been studying angular motion, we've defined counterclockwise motion as positive and clockwise motion as negative. So you can see that a body that is rotating will have an angular momentum, which is L wheel, WH for wheel. In this case, it is directed upwards. And the second step is that after some time, the boy inverts the direction of the wheel, and then therefore the direction of rotation of the wheel then becomes clockwise, and the angular momentum of the wheel, its direction also becomes opposite, so it's minus L wheel. Also, you will see that since the boy moved in order to invert the direction of rotation of the wheel, the boy himself also started rotating, and you can see that he's rotating in the counterclockwise direction. Also, since the boy started rotating, he has a certain angular momentum, which is given by LB. So in this case, in A, we have an initial angular momentum which is given by L wheel. So in this case, the boy himself does not have any angular momentum because he's not moving, he's stationary. Only the wheel is moving. So LB in the first case, in the initial case, is 0, and the angular momentum of L wheel is given by this symbol. So this is the left hand side of the equation, and the right hand side of the equation will be the final angular momentum. The final angular momentum will again be the sum of the boy's angular momentum and the wheel's angular momentum. And in this case, you can see that the boy's angular momentum is represented by LB, and the wheel's angular momentum is minus L wheel. So the sum of all these will give you the final angular momentum, the total final angular momentum. And on the left hand side, you have the total initial angular momentum. Now, what's the problem? I've explained the situation, I've explained the figures, and I've explained the angular momentum of the components involved, and then we've also applied the law of conservation of angular momentum. Now let's go back to the problem again. Like I always said, understanding the problem is very important before you can start solving it, right? So I've already explained that the student was initially at rest, and he is holding a bicycle wheel whose rim is loaded with lead and whose rotational inertia is I wheel. So since this is angular momentum, and this is angular motion, therefore instead of mass, we are talking about rotational inertia. So that is represented by capital I. And for the wheel, it has a subscript WH. Now the axis of rotation is this line passing through the center of the wheel. The angular speed of the wheel here, omega wheel, is given as 3.9 revolutions per second. Okay, so these are the parameters given to you. You have the moment of inertia, 1.2 kg meter squared. You have the angular speed, which is 3.9 revolutions per second. You have the angular momentum, L wheel of the wheel, pointing vertically upwards in the first case. And after in the second case, which is shown in figure B, you see that the wheel is inverted, and hence the angular momentum becomes minus L wheel. And due to the inversion, the boy on the stool also starts rotating, and he has an angular momentum. So this means he also has a moment of inertia, which is IB. I for the boy is given by 6.8 kg meter squared, right? So so this is the whole description of the problem that we have. Now we have written this equation for the conservation of total angular momentum. Now what do we have to find? The question is, with what angular speed omega b, and in what direction does the composite body rotate after the inversion of the wheel? So we have to find omega b, the speed with which the angular velocity or speed with which the boy is rotating. Okay, so what do you mean by composite? You understand the word composite? Composite is a combination of two or more things. So the system in this case is a combination of the boy and the wheel. Okay, right. So the conservation of angular momentum, we've written this: the total initial angular momentum is equal to the total final angular momentum. And therefore, looking at this equation, we can, this is minus L wheel and this is plus L wheel. So we can again write it in terms of the sum of the boys and the wheels angular momentum on one side, and the sum of the boy and the wheels angular momentum in the initial condition and in the final condition. Again, in this case, this minus LWH can be taken to the other side to make it positive. Then this becomes 2LWH is equal to LB. And you have this written over here. Okay. Now, when you have this, you can use the formula. We know that L, the angular momentum, is a product of moment of inertia I and the angular speed omega. So therefore, you have the value for I, right? You have I for the wheel and you have I for the boy, and you have the angular velocity for the wheel. So you can put all these values and then you can determine the angular velocity of the boy, which is what we had to find. And since the answer is positive, what will be the direction of rotation of the boy? Yes. What will be the direction of rotation of the boy? Yes. Rana Shehbaz is not here today. Okay. Yes, what is the, who will answer this? What is the direction of motion of the boy? I've already discussed this. Hello?
Ma'am, if it is positive, then it will be counterclockwise.
Yes, since the answer comes out to be positive, therefore the direction is counterclockwise, right? So you see, the problems are not complicated, but you just don't have to be scared. Just use the concepts. It's very simple. The only concept we're using in this case is angular momentum, which depends on moment of inertia and the angular velocity omega. That's it. So these are the quantities you need, and then you can apply your formula, put in the values, and you get your answer. Okay? Right. Now let's look at another case. Okay, let's look at 11.6. In this case, this is a Ferris wheel. You're familiar with this. These are in amusement parks. They are also available in Lahore. So this is one of the very old Ferris wheels that was designed. And again, there's a lot of physics involved in designing this wheel to ensure that it takes place with safety so that the passengers are not hurt, right? So in this case, you have a giant wheel which is rotating, and it can carry 36 wooden cars. So 36 wooden cars are attached, or carriages are attached to this wheel, and each of these cars can carry 60 passengers. Okay, so the radius of this is 38 meters, and the mass of each car is about 1.1 into 10 raised to 4 kg. So it's quite massive. And the mass of the wheel structure itself, the whole wheel structure, is given as 6 into 10 raised to 5 kg. And because these are all, this is all a metallic structure, and the wheel made a complete rotation at an angular speed omega f in about 2 minutes. So the time for one rotation is 2 minutes. So what do you have to find? You have to find the magnitude capital L of the angular momentum of the wheel and its passengers while the wheel rotated at omega f. Okay, so I would like you to understand this problem, and meanwhile I'll take your attendance. Okay. Okay, let's see. Sarmad, no. Amar, no. Abu Bakr, no. Abu Bakr is not with us. Fatima Babar, no, she's not with us. Usman Bajwa is not here today. Anam Basharat is not here. Bilal Muhammad just sent me a message. There's a problem. So anyway, Hamza Dar,
Yes, ma'am.
good. And Fariduddin,
Yes, ma'am.
good. Kessler is not here. Zarish,
Yes, ma'am.
okay. Haris,
Present, ma'am.
Muaz,
Yes.
okay. Hafiz Ibrahim,
Present, ma'am.
good. Huma Ishad, Alina Khalid, Muhammad Hunain,
Yes, ma'am.
okay. Alina Khalid, you did not respond. Where are you? You know, when I can see your name in the Zoom meeting and you're not responding, it means that you connected and you disappeared. So you're absent basically, right? Alina Khalid, I cannot, you're not responding, but you're connected to the meeting. This means that you disappeared after connecting to the meeting. Is that clear? Okay. अब अलीना वैसे निकल गई मीटिंग से नहीं फिर एंटर हो गई look at what are you doing Rana Shahbaz is not with us today Sania Ahmed is not there Arisha is not there Chand Khushi is not there Maiza
Present, ma'am.
good Yusuf Patras is not there Abira is not there Nadia Mukhtar is not there is she yes Nadia Mukhtar
Present, ma'am.
good Nadia okay Hayan Ahmed
Ma'am?
Hayan Ahmed is not there Cheryl
Present, ma'am.
okay let's see Cheryl okay Ashrab is not there and Huda Zahoor is not there Amelia
Ma'am, Suhaib present.
Present, ma'am.
एक मिनट सुहेब तुम्हारा नाम आया है?
कहाँ पे?
मैंने बोला है आपका नाम
जी मैम अभी बोला है एक बच्चा पहले.
बोला है मैंने आपका नाम सुहेब
जी.
नो मैंने अभी आपका नाम बोला ही नहीं है
ओके मैम.
बिस्मा सिद्दीकुल्ला अब सुहेब आता है सुहेब
मैम प्रेजेंट.
गुड तलहा नो अली जुल्करनैन
Present, ma'am.
yes okay बस खत्म okay good so let's go back to what we were doing
Ma'am?
yes कौन बोल रहा है
Ma'am, Alina Khalid. Ma'am, I'm also present.
बेटा आप क्यों नहीं बोली
I'm
मैंने
just
इतनी
having some
दफा आपका
Wi-Fi
नाम
issue.
बोला है आई हैव बीन कॉलिंग आउट योर नेम इट
Ma'am,
मींस
मैं
आप
disconnect हो गई थी.
नहीं आप कनेक्ट करके गायब हो गई थी आपका नाम आ रहा था मेरे पास लेकिन यू वर नॉट स्पीकिंग इट मींस आप यू वर नॉट देयर ऐसा होता है वी नो दैट वी अंडरस्टैंड दैट ठीक है सो इफ यू आर प्रेजेंट यू शुड
Ma'am, मैंने अभी आपको सवाल का जवाब दिया था वो मैं थी
अच्छा चलो ठीक है आप जब सवाल का जवाब दिया करो ना तो प्लीज आप अपना
न्यूमेरिकल वाले सवाल.
नाम भी बताया करो ठीक है बिकॉज आई कैन नॉट सी यू डायरेक्टली ठीक है सो आप अपना अगर
ओके मैम
हाँ whenever you say anything you also tell me your name right okay let's come back to the question we were talking about this wheel which all of you enjoy in the amusement parks and this is all related to physics so now maybe you will understand it better when you go there so we have been given the values for different parameters in this case and what we have to find is the angular momentum magnitude means we don't have to find the direction we only have to find the value and now let's look at how we can do this how can we do this we have to when you have to find the angular momentum of a body the simple formula is here right what is the formula L is equal to I omega what is I I is equal to the moment of inertia of the body, and omega is the angular velocity. Now, in order to find I, you have to identify the shape of the body, the geometrical shape of the body, and then you can go to the table that we just saw in the last chapter and find the formula for the moment of inertia of the body according to its shape. So what is this shape? What is the shape of the wheel in this case? The shape of the wheel in this case is the shape of a
Circle.
circle. Nahi beta, this is a 3D shape. Circle is a 2D shape. 3D solid shapes mein what will you call this shape? Bolo? Bolo?
Sphere.
Huh? Who's speaking? What is the shape of this wheel? Come on, आपको basic shapes तो पता होनी चाहिए ना? What is the shape of the wheel? Who's going to answer this?
Sphere.
हाँ?
Sphere.
ये कौन बोल रहा है? कौन बोल रहा है?
मैम अलीना मैम मेरा वाईफाई का थोड़ा मसला है.
अच्छा ठीक है. Alina says it is a sphere. Okay, let's see. Any other answers? Will someone try to answer this? So one answer is that it is a, oh my god. Okay. So one answer is that it is a sphere. Do you all agree with this, or do you have a different answer? If you have a different answer, do
Disc.
let me. हाँ?
Disc.
ये कौन कह रहा है?
Fareed.
Fareed says it's a disc. Alina says it's a sphere. Any other answers?
मैम जो अभी आपने पिक्चर्स दिखाई थी उसमें ये हूप की शेप भी हो सकती है.
ये कौन बोल रहा है?
जरिश मैम.
Zarish. Let's go back to the table, okay, and let's look at it, okay. आप लोग भी देखो और मैं भी अभी आपसे शेयर करती हूँ, right? So these are the three choices and I have to take the correct one, okay. So let's see. जो जिसकी सही होगी उसको पॉइंट मिलेगा, right? Okay. So कौन सा चैप्टर है जिसमें टेबल है? In which chapter do we have this table? अब तो हम बहुत दफा इसकी बात कर चुके हैं. We have been doing this several times before the holidays and after the holidays. So which chapter is this? Where do you have that table? You remember that? We just discussed it a short while ago as well.
11th chapter मैम I guess.
कौन सा?
11th.
Very bad. No, it's not. So अपना you please practice and revise. You should remember this. ठीक है. So this is at least ये तो पता हो कि टेबल कौन सा देखना जाके. This is the table. Can you see the table now?
Yes ma'am.
Yes, ma'am.
Good. Okay. So इसके मुताबिक ये कौन सी शेप बनती है? Let's ask the students who talk. अलीना ने क्या कहा था? She said it's a. अलीना ने कहा था. Can you remind me?
Sphere.
Sphere. नहीं, अलीना ने sphere कहा था.
Yes ma'am.
बेटा sphere क्या होता है? Sphere is like a ball. Is the wheel like a ball? Spherical shape is a ball shape. Sphere में भी दो types हैं. एक है solid sphere और एक है hollow sphere. Hollow sphere means वो अंदर से खाली है like a ball or like a balloon. And solid जो होगा वो आप imagine कर लो कोई ऐसा ball जो अंदर से खाली ना हो, जिसके अंदर भी हो. You can think of an example. I think a cricket ball for example, right? अच्छा, जो फुटबॉल का बॉल है वो hollow होता है बीच में से, उसके अंदर हवा होती है. Whereas for the cricket ball, it's solid inside and That's a solid sphere. So we have two types of spheres, and the formulas for the moment of inertia of each kind of sphere is different. Okay, so is it a sphere? You said this. कौन बोल रहा था? Alina? Alina? Alina, where are you? Alina फिर गायब हो गई है. Okay, so Fareed, what was your answer?
I said disk.
You said disk. Okay, do you think it's not a sphere, right? Okay, you said it's a disk. Let's look at what a disk should look like. A disk is again a circular disk is circular, ठीक है, इस तरह से, लेकिन इसकी जो thickness होती है वो बहुत कम होती है, like a CD, है ना? तो CD की shape है, ये हमारी जो wheel है, अंदर से ये सारी full होती है with the material, it's solid, खाली नहीं होती, जबकि हमारी जो wheel है ना, उसके किनारे हैं, but अंदर से it's hollow, so it's not a disk, ठीक है, and it's not a sphere. और जरीश ने कहा था it's a hoop, so it is a hoop. देखो ना ये circular एक structure है, अंदर से बिल्कुल खाली है. Hoop आप लोगों को पता है ना, hoop is also used for playing and for exercise and all that. Hoop के साथ जो करते हैं, you know that is a hoop. Hoop क्या है? It's a, उसकी sides जो rims है circular, वो solid होती है, बीच में से it's all empty. ठीक है ना? तो disk जो है, it's not empty from the inside. Disk is like a CD. It's all solid material with a very small thickness. That's the definition of a disk. Whereas sphere is like a ball. So it's not a ball. A wheel is not a ball. So the hoop is the correct answer. So Zarish will get 1 point today. So please be careful in identifying the shapes. Okay, the meeting is going to end in a few minutes. If the meeting ends, then please click the same link again and rejoin the meeting. Okay. Okay, so now let's go back. I can stop sharing the table. We've identified the shape, and I can now go back here and we can pick the correct answer. It's not a sphere, it's not a disk, but it is a hoop. Okay, so and now I can go back to the problem. Here, this is the problem. Okay, now before I start the problem again, I'm going to end the meeting and you can rejoin the meeting. Okay, is that clear?
Yes, ma'am.
Okay, ma'am.
Good.